All right, today we're going to introduce some new vocabulary. So we're talking about lines, but it's in like a three-dimensional representation. So parallel lines are coplanar lines that are never going to intersect. So you've learned about parallel lines before in algebra. They have the same slope. They never intersect. So what that could look like is let's look at example B right here. We want to find all segments that are parallel to segment CG. So that would be segment DH. Those two segments are parallel. They're never going to intersect. Segment BF, which is over here, CG and BF are never going to intersect. As well as over here, segment, I'm just highlighting it. Segment AE is also a segment that's parallel to segment CG. So parallel lines are coplanar and they are never going to intersect. Okay, so parallel planes are planes that never intersect. So if you think about this prism, we have the top and the bottom. The top and the bottom are never going to intersect. The front and the back are never going to intersect. The left side and the right side are never going to intersect. So if I'm talking about example A, where we're trying to figure out all planes parallel to plane ABD, here's plane ABD, this top of our box. So which plane is going to be parallel to the top? The bottom. So plane EFG would be EFG. That plane would be parallel to plane ABD. So EFG, or I could have called it EHG or FHG. Remember, all you need is 3 non-collinear points to name a plane. The next vocab word is skew lines. So skew lines are lines that are never going to intersect, but they are non-coplanar. So this one's a little tricky. So if we think about segment EH, well, skew lines are different than parallel lines. So we've already covered how parallel lines are never going to intersect. So skew lines are not parallel lines. Skew lines are, instead of being parallel, they are like on totally different planes. So it's like the front and the back, like they're not parallel, but they're definitely never gonna intersect. You're probably like watching my arms. You're like, Ms. Briscoe, what are you doing? So segment EH and, for example, segment CG, which is back here. This is an example of touchscreen problems of skew segments, because EH is like at the front edge of the box, CG is in the back. Like those two edges are never going to intersect. They're not coplanar. They're also not parallel. That's what's called skew. So CG, segment CG, is skew to segment EH. So that would also mean that segment BF is skew to EH. Another one. Okay, so we can literally do process of elimination. So AE touches it, DH touches it, AD is parallel. Okay, so like AB. Segment AB and segment EH are never going to intersect because AB is on the top and EH is on the bottom. So it might look like they're going to intersect, but if you think about, like, a good analogy is like if you think about on a highway. Sometimes the highway splits and part of the highway goes over and part of the highway goes under. So those aren't parallel. Like my two arms right now are not parallel, but they're also not intersecting. Like my top arm and my bottom arm are not going to touch. So this is an example of skew. Think about the highway. Like if those two, like the overpass and the underpass, intersected, then we'd have a whole bunch of car crashes. They're never going to meet. So they're skew. So EH and segment AB are skew, and so then that also means that CD is skew to EH. That segment on the top and that segment EH are never going to intersect. But all of the other ones are either intersecting or parallel to EH. Okay, and then the last vocab word is perpendicular, and perpendicular means that they are segments or lines that intersect to form a right angle. So if we're trying to figure out all the segments that are perpendicular to EH, that would be AE, because AE and EH are going to make a right angle. They're perpendicular. EH and DH are going to make a right angle. Like this is a right angle, this is a right angle. They're perpendicular. But then also EH and FE are perpendicular. Here's a right angle right here. So FE would be perpendicular to EH. And then also GH would be perpendicular to EH. And there you go.